Good morning, students and parents. It's Wednesday, September 2nd, and today we are going to finish up what we started on just the other day on Monday with the safety presentation. I'm going to go through the second half of it. I wanted to split it up into two videos because the other one was already getting pretty long. And also the last part of safety, has to do with jacks and lifts. And I wanted to go outside and show some pictures of that stuff because I've got one vehicle on the lift right now. So I will share the screen or present the screen, and we'll go ahead and get started. So this is where we left off on Monday. This is the first slide in the section about lifting automobiles, lifting an auto with a hydraulic floor jack. So in our shop, we have 3 lifts, 2 two-post lifts and 1 drive-on lift, and those are frequently used nearly every day. But when they are used for other jobs, then we'll use jacks and jack stands to jack a car up off the ground. So I like to train students on how to use both because they will be using both throughout their automotive career. You'll use a jack probably for a quicker repair, like maybe changing a tire or just doing a quick inspection on something. You'll probably use a lift for something that's going to take you more of a couple-hour job to do it. You're not going to pull a car on and off a lift for a 5-minute fix. So the first thing that you should do before using a lift or a jack is to make sure of a couple of things. Number one, if you're going to raise a car up with a jack, you're typically going to be raising it up on one end or the other. So if you're going to jack it up in the front, you want to chalk the rear wheels to prevent the vehicle from trying to roll on the jack or off the jack. If you're going to jack it up from the rear, then you want to chalk the front wheels opposite of where you're jacking up. So again, that's just to prevent the vehicle from trying to roll, because once you get the weight of the vehicle on the jack, if the vehicle decides it wants to roll, it can slip off the jack very easily, and that can damage the vehicle. It could also cause serious injury, and that's just one of the first things that you should always do. You'll also notice that this jack has a label on it, and we'll talk about that label here in just a moment. Okay, do not exceed the weight limit of the jack that is printed on the label. Most of the jacks are going to be rated in tons, so a ton is 2,000 pounds. So 2 tons is 4,000 pounds. Now you got to think about where you're picking the vehicle up. You're not picking up the whole car or the whole truck. You're just picking up one corner of it or one end of it. So if a car weighs 6,000 pounds, then it's probably going to be okay to use a 2 or 2.5 ton jack to pick up just one corner, one wheel, or one end. You're not trying to pick up the weight of the whole thing. The weight limit should be posted on the jack, and it's usually easily visible. Over time, those stickers do wear off, but jacks have part numbers just like anything else. So if you're unsure, you can probably look that up pretty quick and easy. You can also reprint those labels and stickers from the manufacturer for free in most cases, as long as the jack manufacturer is still in business. Then you can print it off and you can just glue it or tape it back onto the jack if the other one is damaged or missing. The load rating is usually in tons, as said before. So 2.5, 3, 1 ton is equal to 2,000 pounds. Never work under a vehicle that is supported only by the hydraulic function of the jack or the lift. Anytime you're working underneath a vehicle, if you're going to take a tire off and work on the brakes, if you're going to go under there and change the oil, you jack the vehicle up and you lower it down onto jack stands. You do not just get under there with the vehicle solely supported by the hydraulic system of the jack, because the only thing that is holding that vehicle up is fluid pressure. That hydraulic jack has seals, and if those seals decide to start leaking or go out, then the car can fall very rapidly, and if you're under there, there's nothing there to protect you. So always lower the vehicle on secure jack stands. Secure meaning undamaged, properly functioning, and they must be actual jack stands. Jack stands are not cinder blocks. Jack stands are not pieces of 4x4 pieces of wood. Jack stands are steel structural devices, and they need to be checked and maintained just like every other tool. If a jack stand is damaged, then it's not secure. You take it out of service, and you either repair it or replace it with a new one. And here's an example. So we've got this rear axle supported by those two jack stands right there, and then the jack is under the front also, just in case you need to make an adjustment going up or down. Okay, lifting a vehicle with a two-post lift, a lot of the same rules apply. Always make sure the vehicle does not exceed the load rating of the lift. Lifts are going to be rated in pounds. So most lifts are going to come in even number ratings. So you've got an 8,000 pound lift, a 10,000 pound lift, 12,000 pound lift. They do make some 7,000 and some 9,000 pound lifts, but they're not very common. The ones that we have here in the shop, we have two post lifts. One of them is a 10,000 pound. The other is a 12,000 pound. And then we have a drive-on lift as well that is a 10,000 pound. The load rating should be posted on the lift, very similar to the jack. Make sure the vehicle is centered on the lift, side to side. Reason being, typically if you're working on a car, you're going to be removing parts. So even if you're going to do something like rotate the tires, those wheels and tires have a weight to them. So if you have more weight on one side of the vehicle than the other, if it's not even, and you start taking these components off, it's going to cause the vehicle to try to shift on that rack. Make sure the vehicle's positioned so that the vehicle's weight is distributed correctly. This is particularly important for pickup trucks, diesel trucks especially. Diesel trucks are very, very heavy in the front. The engines are very, very heavy, and the transmission is underneath the cab. So if you have a crew cab dually truck, you've got probably 65 or 70% of the weight over that front axle. That doesn't leave very much for the rear. So if you raise this vehicle up and don't have anything supporting it, when you start taking things off the back of the truck, if it's a dually, it's got 4 wheels and tires back there. If you take all 4 wheels and tires off, it is possible that that's enough weight off the rear to cause the front to want to tilt down and do a teeter-totter effect. We don't want that to happen. So always make sure that you distribute the weight as good as possible for the lift that you're using. And it also is a good idea to use some of the extendable stands underneath to make sure that the vehicle cannot lean one way or the other, depending on the job that you're doing. Put lift arms under the vehicle correctly so that the pads contact the proper lift points. So on the safety test, a couple of you have already asked me about proper lift points. A pinch weld is a point where on a unibody car, like a Toyota Camry, for instance, you have the outside edge of the body panel called the rocker arm, which is usually underneath, or the rocker panel, I'm sorry, not the rocker arm. It's underneath the doors. So if it's a 4-door car, you got 2 doors on each side. So the rocker panel runs underneath. Then you've got the floor pan. So you have the floor pan, which runs horizontally, and then you have the rocker panel, which runs kind of at an angle. Usually it's curved, and they both have corners. So the corners of these 2 panels are going to meet and butt together, and a lot of times they're spot welded together. Sometimes they're just rolled together with an edge. That's a pinch weld. So you've got 2 body panels that are creased or welded together. It makes it a very strong point. That's an acceptable place to lift a car. Frame rails, if it's a full frame vehicle like a pickup truck, a van, or an SUV, or an older car like a Crown Vic, it has a frame rail running from front to rear. So you can put those lift arms or lift pads directly on the frame rail. You may also, if using a jack, place it on an axle. So if you have a solid front or solid rear axle, also common in pickup trucks, then you may place the jack right there. You typically won't put lift arms on the axles, mainly because they're not that long. But a lot of times you can place, if it's a vehicle that's got leaf springs and a solid rear axle or solid front axle, you can place those lifting arms or lift pads on the leaf spring hanger where the bolt goes through, because it's a good solid point. You just want to make sure that it is solid. For instance, if a car is 25 years old and it is rusty, the pinch welds may not be very good quality because they have deteriorated and rusted away. So even though a pinch weld is an acceptable point on a good car, if you're raising the car up on the pinch welds and you start hearing popping or creaking noises, or notice that it's just caving the pinch weld in, you can't lift it up there. It's not safe. You're going to have to go to a different place. On the opposite end of that, a lot of manufacturers will say, don't lift here. So they may have a arrow pointing that says, do not lift here. That may be a point where you have a fender that is bolted up, particularly important in the front. If you place the rack or the jack there and you start jacking it up, it's not going to raise the vehicle up. It's going to bend that fender or bow it out, and it's going to cause a lot of damage. So you want to make very, very sure before you raise the car up that you have it positioned correctly. In addition to that, before you get underneath the car, once you are sure that you have the lift on the appropriate points, this is something that I always have students go outside and practice, and hopefully we're going to be able to get some small groups of students in here starting next week to do this. You get the vehicle raised up approximately 2 to 3 inches off the ground. So you're just going to hit the lift button, and you're going to get it up to where the tires are just off the ground. Now, why do we do this? If we're going to have a failure, if the lift has a failure, or if you don't have the car positioned on the lift correctly, we want it to have a problem here, right now, 2 or 3 inches off the ground. It might, make a loud noise, car might drop a few inches, and it'll probably be scary, but it's not going to hurt anybody, and it's probably not going to hurt the car because the tires are just this far off the ground. So it's not a lot different than going over a large speed bump. On the other hand, if you wait and check the vehicle and it's 6 or 7 feet in the air, if it falls then, it's going to destroy the vehicle and it's probably going to hurt or kill somebody. So we raise the vehicle up just a few inches and then we're going to shake it. If it's going to fall, it's going to do it right there. That's where we want it to have a problem. If the vehicle is secure, it's not rocking back and forth, it's not making any odd noises, then you're good to go ahead and raise the vehicle on up. Once you get the vehicle in the air, before you start actually working on it, just double check, make sure that the lift arms are contacting in all 4 corners if it's a 2-post lift. Sometimes you might have a situation where it shifts a little bit. As you're raising it up, the vehicle may move a little bit. So you want to make sure that that doesn't happen. If it does, just let it back down, readjust those points, and then give it a second try. If the vehicle moves on the lift or all 4 arms are not contacting, just lower it down and correct that action before going any further. Sometimes it doesn't have anything to do with the setup of the lift. Sometimes vehicles, for instance, if it's a work truck, it just might have a bunch of stuff in the bed. And as you're raising it up, that stuff may start to move around. If it's tools or whatever, they might start rolling. So it might start going up fine, and if all the tools roll over to one side, then it might cause the truck to lean. You might have to let it down, readjust one side to correct for that. Okay, so here's an example, properly centered, and we're actually going to go outside here in a minute and look at this side to side. You don't have to get a tape measure out for this. You can just eyeball it. There's 2 different types of lifts. You've got symmetric and asymmetric. So symmetric, you can take a look here and see where the front tires of this are placed well before those front arms. Symmetric means that all 4 arms are the same length, and we have one here that's symmetric and one that's asymmetric. For a symmetric lift, you're going to place all 4 arms basically in the same position. For asymmetric, the front arms are shorter than the rear. These are very, very common, and they're great for front-wheel drive cars, but they're not so great for super long trucks. So crew cab dually trucks don't work well on these lifts because the front arms are so short, they can't reach out and get where they need to go. So that's what an asymmetric lift should look like when it's positioned properly. Typically, your driver's door or mirror will be just in front of that lift post. And then here is a picture of a properly centered truck, or as proper as it can be. Notice that you've got a lot of bed hanging off the back side of where this lift post is. So if you're going to start taking these wheels off, or if you're going to take the bed off, you want to make sure that you support this vehicle underneath the front and the rear so that it cannot try to teeter-totter or lean back and forth. And this is another good example of why asymmetric lifts aren't preferred for this type of a truck. If this was a symmetric lift, you would be able to get the rear arm a lot further back underneath of this bed on the frame so that it would be a little more stable. Okay, MSDS. This is now referred to as SDS. They dropped the M, stands for Safety Data Sheets. Sheets are on file in a binder in the classroom. These sheets contain important information about any hazardous chemical that we use in the shop. So WD-40, you might not think that's hazardous, but if the can explodes and it goes in your face and gets in your eyes, you need to know what to do. How do you get that stuff out of your eyes? What do you flush it with? Same thing's true for brake cleaner. Anything that we use in the shop, motor oil, the mineral spirits that we use in the parts washer, all those things are kept on file in a great big binder. These sheets are available for anyone to see at any time. So any student in the classroom can see them. Any office personnel can see them. They are public information. They are never to be hidden. They are never to be locked up. They have to have full accessibility for everybody. Sheets include how to handle these chemicals if they get into a cut, if they get spilled in large quantities, how do you clean that up? Some things you can just clean up with water. So if you spill, a gallon of mineral spirits, you can mop it up or hit it with a garden hose, and it will start to dissolve that stuff in most cases. Some parts washers use a water-based solution, so you can literally just pour it down the drain. You can sweep it or mop it up and then just pour it out. If you spill 500 gallons of motor oil, there's certain procedures you have to do for that. You can't just wipe it all up and throw it in the trash can. You've got to call somebody to come decontaminate the area and dispose of the materials properly. Okay, here's an example. If you want to click on this, you can, but all these have the same standards. It's a 16-page or 16-section standard. So each chemical, regardless of who makes it, PB Blaster and WD-40 serve the same purpose, but they're made by two different manufacturers. They may contain some of the same exact chemicals and same exact processes as they're made, but they still have two different sheets. But both of those sheets are going to be very, very, very similar. They have 16 standards, so both sheets will look exactly the same. There may be some things about them that are different, that are listed differently. All right, we're going to skip the review questions. I'm going to pick this up and try to keep it as steady as possible. Go back to the meeting here and stop sharing. We've got a vehicle on a two-post lift right here. So this is one of our two-post lifts, and that's what the main part of this video is. So I want to show everybody, and this is something that I normally will bring students out here and show you this stuff, but obviously I can't do that right now. So all lifts have generic instructions. Hope you can see those. And all lifts operate in a similar manner. So this has several stickers on this side as well. Lifts have to be inspected to make sure that they are in proper working order, and they're inspected every single year. This lift has the weight rating posted on it. This is a rotary lift, but it has a capacity sticker right here. So we know this is a 12,000-pound lift. This is a symmetric lift, meaning that all four arms are the same length. And you can see that we've got a pretty good spread. We don't have a lot of the back of the vehicle hanging off past that rear lift arm like we saw in that last picture. And this lift is centered side to side. This is a full frame vehicle. So you can see those lift arms, they're placed directly on the frame rail, nice solid point. We could not put it on a pinch weld here because we've got this running board in the way. So if the vehicle's got running boards, you may have to use spacers like this. This is also adjustable. It's threaded so you can take it up or down. So this is a very, very good lift for both cars and trucks. Now over here, we've also got, you can see there, you've got different size adapters as well for different vehicle applications. This is a little bit of an older lift, but it has a lot of the same information. So it has those same stickers certifying that it's in good working order. It also has the lift adapters Now you can see what I was talking about here. This sticker, this label, it's kind of falling off. This lift is going on 10 years old. So what I've done is I've just taken this and put more tape on it, and I probably need to put another piece on there. And when it just falls off altogether, I'll print a new one and put it back up there. This is a 10,000 pound lift, and it's a Challenger. Let's see if we can find the weight rating on it. Should be posted on here somewhere. There it is, 10,000 pound capacity. Okay, so you can easily identify all of these lifts. This is our drive-on lift. This is what we use for alignments, and it is very, very similar in the way that it's rated. So we'll find that rating. This also has rolling jacks, and it tells us right here, this is a 9,000 pound lift. I thought it was 10,000, it's a 9,000, and it's got 4,500 pounds per axle. So if we want to pick up just the back, we can use a rolling jack. Using all of these lifts is very, very similar. This particular lift, it has a little console. It's got these buttons. This up here where we can see it a little better. Okay, so we've got a button here that's labeled up for raising. We've got a button for lowering. We have a lock release. All of these lifts have locks on them. So if we go to put this lift down, it locks itself so that you can't accidentally let it down on an angle. In order to release the locks, you've got to hit this lock release. And now it's got a flashing light telling us that we have to raise it up before we can do anything else. The two-post lifts, they have mechanical locking mechanisms. So on this two-post lift right here, we've got a series of buttons and levers. So we've got a button right here. This is what's going to actually raise it. This, you're going to push it in to lower it. But if we just start lowering it, it's going to stop almost immediately because we have to also pull our lever. Now, the lever won't move because it's on the locks. We get it off the locks. Now we can hear them disengage. Okay, this one over here is practically identical. We've got a green button, which will raise it up. We've got that same lever right here that will lower it. And the vehicle stopped because it's on the locks. And the lock release, it's right here. And now it won't move because it's locked down. So practicing using these lifts is something that's essential. It's something that I usually will have students come out here and do, and especially if they're first-year students, I won't have vehicles on the lifts so that they can't make any mistakes. I'll just have them get familiar with the buttons, pushing the button to raise the lift up, and then using the mechanisms to lower the lift down. Hopefully, like I said, we can get those small groups of students in here next week so that we can start practicing those things. There'll be more information to come on that. Mr. Coleman and Ms. Green are working on putting together how that's going to work and what the transportation is going to look like and things like that. So as soon as I get more information about that, I will let everyone know. That is all for this video. If you have any additional questions related to safety, related to the safety test, related to the safety slides, please let me know. You must pass the safety test with a 100%, and you can take it as many times as you need to. As I posted in the stream section earlier, some of you have submitted that. You asked me questions. In the multiple choice answers, it automatically marks them right or wrong based on right or wrong information. But the short answer, where I have you go in and fill out information, for instance, the fire drill question, it is probably going to mark that incorrect. And the reason is I put an answer in there, and in order for you to get it right, you would have to type it exactly how I typed it, and that's not going to happen. As long as your information is accurate, then I will go back in and I will mark it correct after I read it and verify that it's accurate, correct information. So don't worry so much about that. If you miss a multiple choice question, you got it wrong, and you need to go back and figure out what you did. Did you misread the question? Did you guess at the answer? So go back and correct that stuff. Now, I will be going through and making comments on your test responses. So if you tell me something about the fire drill or tell me something about lifts or whatever, and it's wrong, then I'm simply going to comment, this is incorrect. Please review the information and resubmit. If I don't make a comment, I mark it correct, and you don't have to worry about that. So I hope everybody has a good Wednesday afternoon. And again, if you have any questions regarding the safety exam, please let me know. Don't forget to fill out your attendance forms. Some of you still are not doing that as you should. You have to fill one of those out every single day. If you have trouble finding it or can't access it, you can just give me an email or text message. It just says, I'm present today. I know Spencer County was having some issues, and I've told them just to let me know in one way or another that you're doing the work, that you're present. Also, make sure that you comment on a couple of things. In the safety area, just a little bit so you can see my whole head. In the safety area, you've got the safety slideshow, and you were instructed to just comment watched or read or reviewed, something like that, to let me know that you saw that information. A few spaces down from that, there's a safety discussion where you have to answer a few questions. You just answer those in the comments, and I went over that in one of the other videos. So you click comment and then 1, 2, 3, 4 with your answers. Then you take the safety test. So there's actually 3 different things that you have to record for this safety section. It's not just the test. There's 3 different responses that you need to complete. And they're very, very short. It shouldn't take you any more than 5 or 10 minutes to do those. Safety test might take you a few more minutes, but it's still not very long. So if you have questions, please let me know. And I will be seeing you all on Friday during our mandatory live meeting. Don't forget about that. And again, if you have trouble or issues, please let me know.